For 7, the last parametric equations question, we're given a lot of trig here and asked to find two different things. We're asked to find the coordinates where it crosses the y-axis and the coordinates where it meets the line y equals 1. So exact coordinates where the curve crosses the y-axis. So if we were to draw ourselves a little sketch, where it meets the y-axis here, this would be the point where x equals 0. So this is akin to asking ourselves, where does x equal 0? So what I'm going to do is I'm going to take my x definition up here and I'm going to solve it for 0. So x equals 0 equals cot theta minus 30. So we're after, where does cot equal 0? So you might suddenly think about, well, this is 1 over tan. But there's this 0 here, which makes it a little bit more difficult to think about. I'm going to draw myself a tan graph. So we start off with a tan graph, and a tan graph looks like this. So it goes up here, there's an asymptote, it goes up, up, it goes up. So this is 180. If you remember when we were drawing the other graphs in lessons, the cot graph is this one. So it goes down like that, and down like that, and then it comes down here, and it goes through here, and it goes through there. So this is cot. So we're after these 2 points here and here at 90 and 270. These are the points where cot gives us 0. If it's any number other than 0, you can just flip it upside down and do tan. But the values that we're after here is theta minus 30 equals 90, or theta minus 30 equals 270. So we get theta equals 120 or 300. So you might look at these and think we've got our answers immediately. But we're after, if we go back to this, we're after the exact coordinates. So we need to know the y values, not just the theta values. So putting these back into here, we've got y equals sine 120 plus 3 cos 120, and we've got y equals sine 300 plus 3 cos 300. You either now need to know your exact trig identities or put these straight into a calculator and get out some answers. So this one gives us y equals 3 root 3 minus 1 all over 2, and this one gives us y equals 1 minus 3 root 3 all over 2. So these are our two y answers. So we're after coordinates, so this is going to be x is 0, because we put this in up here, so it's going to be 0, comma 3 root 3 minus 1 over 2, or this one here, which is 0, 1 minus 3 root 3 over 2. And those are our 2 points. For part B, so you're going to find a different sheet of paper for this. For part B, we're asked to express it in this form here and find the coordinates of the points where it meets y equals 1, giving your answer to 3 significant figures. So this form here first is our first step. So we're going to write out our sine theta plus 3 cos theta, because we know we're going to want to set this equal to 1 eventually. So we've taken our y expression here, like we were told to, by expressing y in this form here. So it's the r sine plus version. So this is going to give us r sine theta cos alpha plus r cos theta sine alpha. What we need to do is work out values for r and alpha that make this work. So all we're going to do now is compare our coefficients. So we've got sine theta here and this one here, and we've got that one. So if you imagine there's an invisible 1 in front of this, because that's how many sine thetas we have 1 equals r cos alpha. We're now going to do this one, so I'm going to do with double underlines. So we have 3 cos thetas here, and here we've got r sine alpha cos thetas. So we get 3 is r sine alpha. Now there's a neat trick for these, because these are essentially simultaneous equations. If we square them both, we get sine squared plus cos squared, which all cancels out and gives us 1. So we can do r squared is 1 squared plus 3 squared, which is 10. So we get r is square root 10. We can also do sine over cos to give us tan. So we get tan alpha is the sine one. The r's are going to cancel here. So we've got 3 over 1. So we get alpha is tan minus 1, 3 over 1. We're going to have a very quick check here whether we're doing this in degrees or radians, and we can see that this is done in degrees. So we can grab our calculator, we can do tan minus 1, we're going to get alpha is 71.6 degrees. So in order to express this, we're going to write out y equals, because this is y, we've got our r, which is root 10 sine theta plus, and we've got our 71.6 degrees. So we've done that bit. We were asked in here, expressing y in the form that, or otherwise is usually a trap. Find the coordinates of the points where it meets the line y equals 1. So we need to set this equal to 1 and solve it. So sticking these in here, we get root 10 sine theta plus 71.6 equals 1. We're going to divide by the root 10. So we get sine, I'm going to call this a, just going to make a replacement here, is 1 over root 10. And our new range, if you remember, we've got to add on this 71.6, is 71.6 less than a less than 431.6. That's what happens if we take our, because we're told in here this is between 0 and 360. If we add on 71.6, our new range for A is going to be between there and there. This is one way of looking at it. If you have another way of finding multiple solutions that you're happy with using, by all means use that one. So I'm going to find my 2 answers that give this one. So if I do sine minus 1 on a calculator, I'm going to get A equals 18.43. And the other one comes from the sine graph. So we've got my 18.43 here, which is 180 minus that, which gives us 161.56. We should be able to notice now that this one is not in our range, and this one is. So we're going to need to find this next one over here, because this one is probably going to be in our range. So this is this one here, add on 360, which gives us 378.43, which is in the range. The next one isn't going to be. So we've got these 2 answers that work. All we need to do now is find theta. So we can find theta by doing theta equals, we just need to take away our 71.6. A minus 71.6. So we take 71.6 away from these, we get theta equals 89.96 or 306.83. We're asked to do it to 3 significant figures, so this is 90.0 or 307 degrees. Now finally, this actually wasn't what we were asked to find out entirely. We are asked for coordinates, so we need to find the x values for these. So these have all got y equals 1, but we can put these in here into the x definition, which is here, on a calculator to get our values for the other one. So it turns out that our 2 points are 0.578, 1, because remember y equals 1, and by putting this one into our x coordinates, we get minus 0.120, 1. And those are our final answers.